Welcome, how you doing? This is another Khan Academy support video. Specifically, we're going to be looking at the third assignment on inequalities this week. We're going to be looking at the one called Testing Solutions to Inequalities that you can see me highlighting here. So this tests our knowledge. Do we understand what these inequalities really mean? An inequality, recall, is saying one side of the expression is smaller or larger than the other side. So in this case, in typical Khan Academy, sometimes they give you a tougher problem to start. The inequality that we're provided with, it says, I'm going to write this down on my whiteboard here. It says 2 needs to be greater than or equal to y divided by 5 minus 1. And then we see here, they say which of the y values satisfy this inequality. In other words, which values for y could we plug into this equation so that the inequality would actually be a true statement, so that 2 would be greater than or equal to whatever y divided by 5 minus 1 makes. So there are two ways to go about this. I think the most straightforward way, and especially if you haven't solved inequalities yet, is that I can go ahead and I can plug in these numbers. So the first thing I'm going to do, I'm going to look at A. It says y needs to be equal to 15. So if I make y equal to 15, I'm going to go to this inequality and plug in a 15. It says 2 is greater than or equal to 15. That's what I plugged in for y, divided by 5 minus 1. And 15 divided by 5, now I've got just numbers in this inequality, so I'm going to evaluate. And I'll make the whiteboard a little bit larger as we do this. 15 divided by 5 is 3. So the inequality, now after I plugged in a 15 for y, says 2 is greater than or equal to 3 minus 1. And when I do 3 minus 1, I get to 2. So by plugging in a 15 for y, the inequality evaluates or states 2 is greater than or equal to 2. Is that a true statement? Is 2 greater than or equal to 2? Yes, that's a true statement. The other two possibilities, so that tells me, yeah, 15 could be an answer, because when I plug 15 into this inequality, 15 divided by 5 gave me 3, 3 minus 1 gave me 2, and it did make the inequality a true statement. Now the next possibility, the next possible answer is I could plug a 20 in for y. So I'm going to erase my work, I'm going to come back here, and this time I'm going to replace y with 20. So it says 2 is greater than or equal to 20 divided by 5 minus 1. I'm going to do that math. 20 divided by 5 gives us 4. So the right side of the expression now says 4 minus 1, and 4 minus 1 is going to give us 3. So now the inequality says 2 is greater than or equal to 3. And I know that's not a true statement. 2 is less in value than 3. So when I plugged a 20 in for y here, it didn't work. It made an inequality that makes no sense. The inequality is claiming that 2 is greater than or equal to 3. So B cannot be a correct answer. C says y is 25. So if I go back into this inequality and I replace the y with 25, that becomes 25 divided by 5 minus 1. Substituted y and replaced it with 25. When I do 25 divided by 5, that gives me 5. And 5 minus 1 gives us 4. So when I plug 25 in for y, the inequality tries to state 2 is greater than or equal to 4. That's also not a true statement. Just like 20 was too big for y, it made the inequality false. 25 is also going to be too large of a value. So the only answer I'm picking here is A. And again, I got there by substituting in and then replacing. One thing I could have done, and I'll show this quickly, later on we're going to learn how to solve inequalities. So another way to attack this assignment would have been just to solve this inequality for y. Similar to when we solved equations, I would add 1 to both sides of this inequality to try to get the y all by itself. So again, this is just a second method that I could have used instead of plugging the numbers in for y each time. I add 1 to both sides, that changes the inequality to say whatever y divided by 5 is, that better be less than or equal to 3. I could multiply both sides of this inequality by 5, to get rid of the divided by 5, and that would give me y is greater than is less than or equal to 5 times 3, which is 15. So if I had taken this approach instead of substituting in for y each time with the answers, if I had just gone ahead and plugged in, then ultimately I would see y has to be less than or equal to 15, and the only answer here that lines up, same answer I got by substituting in, y equals 15 is the only one that satisfies this y has to be less than or equal to 15. That method might make a bit more sense when you get to the end of this week. I think for this assignment it makes most sense to just substitute the values in and see which ones work. So I'm going to do the rest of this assignment by substitution. I'm going to keep testing these solutions by plugging them into the inequality. So the next one we see here, it says 10 needs to be greater than or equal in value to whatever j plus 5 makes. So here the first answer I'm going to plug in, and the first answer I'm going to test, it says j needs to be equal to 3. So I'm going to plug a 3 into this equation. The j, which I'm going to put into a different color, is going to be getting replaced each time, and this time I'm plugging in a 3 for it to test the first answer. So it says 10 is greater than or equal to 3 plus 5, because that's what I'm plugging in for j to test the first solution. When I do 3 plus 5, I get 8. So the inequality simplifies to say 10 is greater than or equal to 8. Is that a true statement? Is 10 greater than or equal to 8? Yes, that's a true statement. So for that reason, j equals 3 is one of the solutions that works in this inequality. But inequalities have lots of solutions. They want us to know, could j equal 4 or could j equal 5? So this time now I'm going to plug in a 4 for j. It would transform or become now 4 plus 5 on the right side, and that simplifies to make 9. So when I plug a 4 in for j, when I set j equal to 4, the inequality boils down or simplifies to say 10 is greater than or equal to 9. That's also a true statement. 10 is greater than 9, so I'm going to pick B as one of the possible answers or solutions for j here. And then the last answer they want us to test, it says j is equal to 5, so I'm going to plug in a 5 for j. The inequality, once substituted in, now says 10 is greater than or equal to 5 plus 5. 5 plus 5 would give us 10. So our inequality now states 10 is greater than or equal to 10. Now 10 is not greater than 10, but it is equal in value to itself. So because this inequality includes the greater than or equal to symbol, 10 equals 10 is also a true statement. All three of these answers, j could be 3, 4, or 5, any of those numbers would make this inequality true. So they're all solutions. For the next question, I would encourage you, if you're still watching and not transitioning to doing this assignment on your own now, if you're still watching, try to do this one on your own, and then I'll provide my help. So here it says 7 is less in value than whatever z divided by 2 plus 3 makes. And I'm going to change that z into a different color because that's the variable that we're going to be replacing here. The first answer they want us to test, if z could be equal to 8. So that's the first number I'm going to plug in for z. So now it says 7 is less than 8 divided by 2 plus 3. If I do 8 divided by 2, I'm going to get 4. So now this, as I start to do the math, as I evaluate and simplify this inequality, 8 divided by 2 gives me 4. 4 plus 3 gives me 7. So this inequality is now trying to state that 7 is less in value than 7. That's not true. They're equal to each other. So for that reason, I cannot pick an 8. Z cannot be equal to 8 because that would produce an inequality that's not a true statement. 7 is not less than 7. The next thing I'm going to plug in, the next answer they want me to test is 9. So this becomes 7 is less than 9 divided by 2 plus 3. If I know 8 divided by 2 is 4, and if I know 10 divided by 2 is 5, I know 9 divided by 2, right in the middle, is going to be 4.5. So when I do 9 divided by 2, I get 4.5. When I do 4.5 plus 3, I get 7.5. And now my inequality says 7 is less in value than 7.5. That's a true statement. $7 is not as much as $7.50. So if I made z 9, that works. I'm also going to make a prediction here, because when I made z 8, it made this 2 exactly equal. When I made 9, now this side was bigger. If I make z 10, it's going to make this side even larger. So I know that z equals 10 is also going to work. If I wasn't positive, I could plug that in and check. But at this point, I should be recognizing, well, if 9 made the right side bigger than the left side, then 10 is also going to make it bigger. 5 plus 3 is going to ultimately give us 8. So this confirms my prediction. Yes, if z equals 9 works, it turns out z equals 10 is also going to be one of the solutions to this inequality. We'll show one more example. At this point, I don't think you should still need these examples. Hopefully you've closed the video out and you're now just going through the Khan Academy examples on your own, but I will show one more example here. I'd encourage you to try to figure this out yourself at first. Oh, let me get my picture out of the way. So we see it says the inequality says 6 needs to be greater than or equal to whatever h divided by 2 is. Typical Khan Academy assignment, the last question's almost easier than the first few ones. They've given us a simpler inequality here. We just take h divided by 2, and that needs to be less than or equal to 6. So the first thing that I'm going to replace h with, again, we'll put that h in orange. That's our variable that's getting substituted out as we test these solutions. I'm going to plug in a 12 for h because that's the first solution they want me to test for h. 12 divided by 2 is going to give me 6. So when I plug in a 12 for h, the inequality says 6 is greater than or equal to 6. That's a true statement. 6 isn't greater than 6, but it is equal to itself. So a could be an answer because it spits out a true statement in the inequality when we substitute h for 12. Now I'm going to plug in a 14. It says 6 needs to be greater than or equal to 14 divided by 2 because that's what I'm substituting in for h. 14 divided by 2 gives me 7. So now the inequality says 6 needs to be greater than or equal to 7. That's a false statement. 6 is less than that. And tapping back into our knowledge from the last problem, if I plug a 16 in here, if 14 divided by 2 is too big, 16 divided by 2 is going to be too big. So B and C are both going to make the right side too large. The only answer is A. That gets you to the end of this assignment. If you have any questions, if you're struggling on your own, I would encourage you to use the Get Help feature when you miss the questions, to watch Sal Khan's videos, and you can also always feel free to email me, and I'm happy to jump on Google Meet and give you a little one-on-one support if you're still struggling. Thanks for watching to the end of the video. Keep up the great work.